In this video, I want to explore the usage of a very useful feature that is on our graphing calculator. It is the usage of the table on our graphing calculator. And I think we can, and we definitely should, derive at a meaningful way to make use of table to help us to solve problem instead of treating it as just another process where we're going to just press some buttons and add some number and insert some numbers into our graphing calculator. Let's take a look at this example here, a simple one, and let's see how we can make use of the table to help us to meaningfully find a solution to this question. Okay, so Tom here, he has 200 marbles to be packed into bags. The first one, he's going to put 30, and the next one, he's going to put 30 more than the previous one, which means that the next one is going to be 30 plus 30, 60. Then after that, 90. Let me write it down. So for the very first bag, Tom is going to be putting in 30. Then after that, he will be putting in 60. Then after that, he's going to be putting in 90. That is what the question says, and he's going to continue with this process until when there is not enough marbles for him to fill the bag in the same manner. So what we can plan to do is, how about let us see how many of such marbles can be placed into the bag in this manner. So we want to find the sum. So this plus all the way until the very last bag. And to notate this, I am going to use Sn. So Sn represents the marbles in the first bag plus the marble in the second bag, third bag, all the way until the nth bag, the last bag. So all the way until the nth bag. Okay, so what we are seeing now is an arithmetic progression. An arithmetic progression with the first term as 30. The common difference is 30. And the number of bags, which is n number of bags, tells me that the number of terms in this arithmetic progression is n. So we can actually do a sum using the arithmetic progression formula. This is going to be equal to the number of bags, n over 2. Then 2 times of the first term, 30, then plus n minus 1 times the common difference, like what we have discussed, it is 30 also. If you were to work this out, you will be getting this as a 15n, then n plus 1. So let's think about it. What we want to make sure is that the marbles are going to be placed into the bag in the same manner, the maximum number of marbles, because that will tell us how many marbles are going to be left, how many marbles cannot continue to be placed inside the bag in this manner. So what we want to do is to make sure that the total number of marbles should not exceed the total number of marbles that are placed in the bag should not exceed the total number of marbles, which is 2,000. We can definitely do an inequality for this, but the calculator can also give me a very meaningful way of doing a bit of trial and error. So if I were to just try plug this into the calculator, so let's say we press y equal on our graphing calculator, putting this 15n, n plus 1 into y1, which is giving me, which I'm going to press it as 15x, x plus 1. What we want to do is to let the calculator help me. We have to do this quickly, because if I were to be using my own mental sum or pressing the calculator manually to let x be equal to 1, which means that I'm going to be getting a S1, which means 30, right? 2, that means S2, which is 30 plus 60. It is going to take a while, because my aim is to just keep pressing in numbers so that I can check when will this be more than 2,000, and that is not going to be working anymore, okay? So our calculator can help us to do this by making use of tables. I just need to trigger this feature over here, second graph. It gives me a table, can you see? So this table should be read in a meaningful manner. X that is there represents n, so it is the number of bags. Y1 that is there represents this, which is Sn, which is the total number of marbles that are placed in the bags in that manner that is described by the question. So as predicted, 1 here is S1. Okay, we are seeing 1 bag, 30. 2, this will be S2. So it is 30 plus 60, 2 bags, 30 plus 60, 90. Then after that, S3, it will be 30 plus 60 plus 90, 180. So what is our goal? Our goal is to let the calculator do this trial and error process for us by substituting different values into the expression. And because the calculator can do it very fast. So let us just try to scroll and see when the total number of marbles needed is going to be first more than 2,000. Okay, I already see it coming, right? It is here. Okay, the last bag is going to be the 11th bag, and after that, the number of the number of marbles that are going to be required will be more than 2,000. So, there cannot be the 12th bag. Okay, which means that the total number of marbles that are going to be packed in the same manner will be 1980. This is S11. So coming back to this question, okay, let us write it down first, okay? So on our table, we know that when the number of bags, let's see, when the number of bags is 10, okay, then Sn, which is this 15 and n plus 1, representing the total number of marbles that are being packed. When n is 10, according to here, it is 1650 marbles. When it is 11, here is 1980 marbles. When it is 12, this is 2340 marbles. So the maximum number of bags that I can go will be 11 bags. And to answer this question now, find the number of marbles that are going to be left unpacked. So this is the number of marbles that are going to be packed. So the number of marbles that are going to be left unpacked will be 2,000 minus away the number of marbles that are packed. My answer here is 20.